This video clip will talk about mapping. What's the meaning for mapping? Functions are defined based on two numerical sets. If at least one set is no longer the numerical set, then the correspondence-like function will be called a mapping. That means function is actually the special case of mapping. Previously, we have seen the equation for the free-falling object. Over there, the time set and the distance set, those are numerical sets. So in that way, the function, that was the function. But you may also say, that's a mapping, it's fine. But we say function is the special case of mapping. So in that way, in that case, we say free-falling object is actually the analytic expression is a function. And recall that we also did the men's set with the social security number. Then men's set is no longer the numerical set. So for the people's set corresponding to social security number, we may not say that's a function. We say that's a mapping. Okay? Because the people's set is not a numerical set. Okay? But mapping and functions are almost the same, because the only difference is one set could be the non-numerical set. For the function, both two sets needs to be numerical set. That's the only difference. Now, recall how was the function defined? In this case, from A to B, x1 corresponds to y1. x2 corresponds to y2, but concurrently, x2 also corresponds to y3. So in this case, for x sub 2, there are more than one elements in B corresponds to element in A. So we say this correspondence is not a mapping. So the definition is like the function. Yeah, but the only difference again is because one of these two sets, or both, could be no longer the numerical set. This is the diagram. This is the diagram. For the algebraic expression, x1, y1, x1, y1 is represented in this way. x2, y2, x2, y2, x2, y3, x2, y3 also represented in the algebraic way. So once you see x2, y2, x2, y3, then you can immediately claim that this kind of correspondence will not be a mapping, because again, x2 goes to y2, x2 also goes to y3. So in B, the elements are not unique, corresponding to the element in A. So the definition is like the definition of function. So one-to-many, not a mapping. 1 to 2, not a mapping. Make the whole correspondence. This is the whole correspondence, not a mapping. All right. Here we did is one-to-many. But there is another case is many-to-one. You see this case. x1 goes to y1. x2 goes to y1 as well. So in this case, it's still a function, or it's still a mapping, because for x1, there is a unique element in B, corresponds to x1. For x2, it's the same. There is a unique element in B, which is y1 corresponds to x2. So in this case, many-to-one is still a function. Okay, so you may write in this way: x1, y1, x2, y1, and that's fine. Because the elements in B, the second coordinate, is unique, corresponding to the elements in A. Okay, there is a unique element in B corresponding to the element in A. So that's different thing from the first case. Of course, this case is easy to understand. For each element in A, there is a unique element in B corresponding to the element in A. Okay. Then you know for mapping, those two cases, they are mappings. Then we call the elements in A pre-image. Elements in A are pre-images. So that's why I wrote here. Elements in A are pre-images. And elements in B are called image. So mapping is actually, they have a direction. Okay? Yeah, mapping is also denoted in this way. All right? Yeah. And here, the Y is the image of X. Y is the image. X is called the pre-image. Okay? So mapping or function, they have a directions. Okay? So if you want to see the direction in this case, which way goes which way? Here is from A to B, so set A will be pre-image. Set B will be the image. Okay, you can click. You see elements, numbers goes to the set, goes to the point set on the real number line. Okay, that's right here. Right here. For this special case, you see every element in A goes to unique, but you can trace back every element in B. Actually, there is a unique pre-image. So this one is also called, this kind of relationship is also called one-to-one. Later on you will see one-to-one correspondence. So that's why we have this kind of mapping as well. Every number corresponds to a point on a real number line, but every point on the real number line has a unique element goes back to a number. So this kind of correspondence, this kind of mapping is one-to-one mapping. Okay? In our case here, numbers are like X, points are like Y. The direction of this mapping is from number goes to the point. Okay? You may click on that to, make those things stick in your mind. All right? Okay, I'll see you.